So let me see. I think I made a... Yeah, let's do this. I like it. So what have I said? Find the area between f of x and g of x. Here is f of x. Here is g of x. There's an area in between. Now, let me ask you, I'm going to let you guys copy down that very Christmassy graph. Just want to be like stores and have decorations up way too early. What is this? Let's say, so this is from A, it might be 0, who knows, to B. So what does this represent by itself? What does that represent by itself? Under f of x. And in fact, what's a better way to say under? Because what's the ground considered to be for just an integral sitting there? Yeah, the x-axis and the function, right? So that would be this area here. Is that cool? All the way down to the x-axis, below f of x. Is that cool? And what would this represent? Probably the same thing, except instead of saying f, you said g, right? And that would be where? That would be this area. Right? So what physically makes sense to do if I only want the green area? Subtract. Isn't that silly? It's amazing. So all I do is subtract those. So you get the area that I want to. So what's really important here? Why is it important that f is here and g is over there? Yeah, f is the one on top, right? So part of this problem is going to be, depending on the way they give you the problem, the first way they give you the problem is the first way we're going to look at it. You have to find where they meet so you know what the limits are. And then you have to figure out who's on top, who's on the bottom. I like it. So let's do a problem. So let's say that find area between I like it. Take a minute, sketch a rough graph, but show yourself some scale of those two functions. Just sketch a graph. So let me put it up here. A, sketch, graph. F and G. B, use algebra to determine where they meet. So these questions, this whole thing right here, is something I could have asked you on the very first day of class. You should have been able to do it without much trouble. Right? What can you tell me about this guy? Anything? As a who? Parabola. I like it. Not just one bola. And they're calm, so they're not hyper. I like it. Yeah, it's all kinds of stupid jokes in math. I love it. That's one I like. And what else can you tell me? It opens up because it's positive x squared. Right? Opens up. What else can you tell me? Very important. More detail. No? You can't tell me any detail? I don't know what the hell you've been doing then. Me? I don't know. What's the x-intercepts? 0 and 4. Can you guys see that? Take an x out. X times x minus 4, 0 and 4. I mean, these are things that should just be automatic things you look at. It really should be. So let's see. Let's call this 2, 4. So 0 and 4. So the vertex would actually be at x equals 2. And at 2, it's 4 minus 8. Negative 4. Looking ahead, I'm going to have to be able to go to 16. So let me make this axis 4, 8, 12, 16. So at 2, it's at negative, what was it? 2, 8 from there to 4. So there's that guy. Woo-yah! Woo! And then this guy, that's a parabola that opens down. The y-intercept is 16. 0, 16. And it opens down. Let's see, what else can you tell me? What are the x-intercepts? 16 minus what is 0? You guys cool with what I'm doing? How do you find the x-intercepts? You make the thing equal 0. Okay, well, when is 16 equal x squared? When x is 4 or negative 4. I like it. So I've already got one place where they meet, and I see the second place they meet. And I can make a guess as to what it is. It looks like it's negative 2. More than likely it is. But my sketch is not the best, so I'm not going to do that. That's why there's part B. So one answer I already know should be 4. The other one looks like it should be 2. Now how do I do part B? Yeah, set them, I think I heard somebody set them equal to each other. Because what I want to do, I want to see where they equal each other. Okay, I'll set them equal to each other. I love the idea of if I force this to equal this, I force it to tell me, I always think about putting it in a chair, turn the light on, tell me where you cross. So I do this and I force it to tell me where this is true. Add x squared, subtract 16, divide by 2, and then how do you factor this thing? Use quadratic formulas, just slap yourself. How do you factor this thing? Yeah, negative 4, I like it. Everyone's negative. So you get x equals 4 like we knew, and negative 2 like we guessed. So what the shit's that mean? what did we just figure out? Yeah, the endpoints for the integral. I love it. So for part C, it would be, of course, find the area between. So the integral from negative 2 to 4. Now who's on top? Beautiful. Do you see how skipping the rough sketch could hurt you a lot? It always does. It finds a way to hurt somebody. If you don't sketch the graph, you're going to assume the wrong thing about which one's first. So obviously the down parabola is on top. So you want to do this area minus, and then the next thing people make a mistake about is they do this silly thing. What if I made a mistake? I didn't subtract the entire function. It's that function minus that function. Really simple little things. All right, go ahead and finish that up. So now, what do I find for this guy? Antiderivative, I love it. So we made the connection now between, this is asking for an area, and to get the area, I can just get the antiderivative. Thank God. I don't have to do the whole limit as n goes to infinity, sum I equals 1 to n rectangles. Oh God. I can now just find this guy's antiderivative. What's this mean? This is beautiful. Yeah, just take a factor 2 and put it up. And that's going to be from -2 to 4. I don't need the plus c because it's a definite integral, so the c's would cancel. And now it's just a bunch of plugging in numbers. Oh yeah, I like this. That's right. Watch this. It's kind of cool. This is a little tiny thing, I know, but watch this. It's kind of cool. It happens on left in math. A whole 64 minus 2/3 of 64 is 1/3 of 64. You guys see that? A whole 64 minus 2/3 of 64 is 1/3 of 64. So that's 64 over 3. Don't need freaking like denominators because they're both 64s. So I should be able to do it a better way. Then I get plus 64 minus 16/3 minus 8. So what do I end up with? I get 42/3. Sounds like it's doable. 42/3 is 14. 14 plus 64 minus 8 looks to be 70. Is that what you guys got? Did anybody get all the way to the end? What's up? You guys all right? I love you guys. You look like... What happened? It's stupid? What?
I'm still working on it.
Oh, you're still working on it. Okay. All right, now, all right. Are you all decent about definite integrals? It's all about finding antiderivatives. And the better you are at taking derivatives, the better you are at finding antiderivatives. So this step to this step, relatively easy, especially because it's polynomial, right? Those you just eat for lunch. Then this step to this step, you're just plugging shit in, right? You can do it all in the calculator, sure, whatever. Now I want to show you a funky little something. Now just stay with me for a second. You guys see the shape we're working with here? Does this sort of look like a rectangle? Isn't that the area we're trying to get, is this area in here? Is it a rectangle? No. But it sort of looks like one. This is 16, so let's say this is 17. And let's say this is, I don't know, 3 or 4. Let's say 4. What's 4 times 17? 68. That's a roughly good. Now, what the hell's my point of that? We're finding areas. You can estimate an area if it looks close to a shape you know the area of. You with me? So the estimate could be really wrong if you're underestimating some curve or something. That is not a rectangle, but it looks sort of roughly like a rectangle. Anyway. I love you guys. Okay. Let's do another one. Let's do one that's a little different. Let me see if you guys can handle this. Same idea, same exact things to do, except now our functions are those two. Just make sure you're thinking correctly. This is still going to be what kind of a shape? Yeah, but now it's opening sideways. Not a big deal. Here I found the x-intercepts, because it's all about x. Here I can immediately find the y-intercept. Okay, keep going. Try to sketch a graph of the region and then use algebra to figure out where they meet. Same exact instructions. Overly horrible. Can somebody tell me the y-intercepts? Nope. I mean, you're working with just this, right? 0, -1. So the first step is to sketch a graph of each of them. This is all about finding where they meet so you can see what area we're talking about. So you haven't combined them yet. So it's definitely going to be 0 and -1. Which means the vertex would be somewhere back here. If you do the work, it actually comes out to be right there. So then you got, woohoo! Rough sketch, so it doesn't have to be too nice. And then this one, what's that look like? A line, so it's the negative of this, so it's that. So I'll let it be right there, right there, right there. So, so we're talking about this weird little area here. How are we doing? Okay, all right. Now, all right, so you unfortunately probably didn't get the most practice with sideways shit. And part of your brain should be cool with the fact that X and Y are completely arbitrary choices. Every x function, I can make a y function and just turn the graph around, and all the work's the same. It's just this, right? So in general, you can't do this always. But here I could have just made x and y and switched them. The whole graph would have just been this way, and the area would have been the freaking same. You see that? Okay. But you got to get used to working with things either way, because that's going to be a huge part of later stuff. So now everything is this way. When I did this problem, it was all up and down. Who's on top, who's underneath. This way is who's to the right, who's to the left. So which one's the bigger function in this region? The which one? All right, so everybody do this.
Makes sense.
Who's on top?
The other one.
This one's on top. Why is this one the bigger one? Because its outputs are bigger over the whole region. What are the outputs here? What variable are the outputs? X's. Where are the X's bigger? This one. So this is the top function. And then the bottom function is this one. So what did you do for part B? You said to set these equal to each other. You add the y over, you get 2y. So it confirms what I sort of see in the picture here. They meet at y equals 0. That makes sense. And they meet at y equals -2. That sort of makes sense, right? Of course, my rough sketch isn't going to be perfect. I don't want them to be perfect. If they're perfect, that means they didn't come from you. So what do I do with these? So what's my d something going to be? It's going to be integral d what?
Y.
Yes, because everything's functions of y now. And these, I really want you to start to make this connection. When I made integral dx, what is this? What are those? Those are values of x. Those are what x goes from to. So here, this is going to be integral dy, so I need what y goes from to. And of course, y goes from -2 to 0. Don't flip everything, because then you get negative stuff. Negative areas, right? It goes from -2 to 0. Let me get you to realize this a different way. As I go from -2 to 0, what do my x's do? They go from this to this. So as y goes from -2 to 0, my x's go between these two things. The same way over here, as x went from -2 to 4, my y's went between these two things. So I like to think of it, when you set up the interval with the limits, you're sort of scanning a section. So I can scan this way, or I can scan that way. Yes?
What if you did it from 0 to -4?
Then your answer would be the negative what it's supposed to be, right? Integral a to b is negative integral b to a. So what do I put inside?
-y.
Good, because that's the top.
Minus y squared plus y.
Like. So go ahead and finish that out. Now right now, some guys might realize, if you did flip those, you could just make everything positive. That is a good thing to realize, because you don't like to have a bunch of negatives running around. You could totally do that. Of course you can. You don't have to do what I just did. But that's what I told you would be a good idea to do. If you switch the limits, it becomes the negative integral, and all the negatives cancel. That's really kind of nice. Do you have to do that? No, shit. You can just carry the negatives through the first. Either way, you should get the same answer. Let's see. So what is the integral of that stuff? That's nice. What's the integral of 2y? Y squared. Or antiderivatives, sure. But now integral and antiderivative mean the same thing, the way that derivative and slope mean the same thing. And then the integral of y squared. And I'm going from 0 to negative 2. When it's a nice, everything's got a y in it, so the 0 part I don't have to worry about it. It's kind of nice. So when I plug a negative 2 in, I get 4 minus 8/3, which is 4/3. All right. Now this one, this shape, it's a I don't know, it's a knife without a handle. I don't know what this shape is. It's not quite a banana. Later we'll see a banana shape. So I can't really, maybe I can kind of make it look like a rectangle or something, but don't try to do that in general. I just wanted to show it to you once. That if it kind of follows a shape that I know the area formula for, I can actually get an estimate using that area formula. Because that's what we're trying to find, is area. Okay. Maybe. All right, here's one more for you to try, and we're going to use this one later in a different way. So this one you definitely want to keep track of. This is a different type of way for them to give you a problem. So let me give this to you. I already got this part right. So I can say, find the area of the region. Here we go. Bounded by So first thing is just get your graph of it. What's another name for x equals 0? No. Must be the other one.
The y-axis.
Y-axis. What's true about every point on the y-axis? The x-coordinate is 0. So that is a definition of the y-axis. So what's the definition of the x-axis? Y equals 0. So when you see those in these problems, and you'll see a ton of problems exactly, find the area of the region bounded by blah, blah, blah. When you see y-axis, or when you see x equals 0, you think y-axis, and vice versa. When you see y equals 0, you think x-axis. So when you sketch a region, that's going to be a wall. So go ahead and try to sketch this region. So one wall is the y-axis. Another wall is y equals 8. And then the last wall is y equals x cubed. When does it run into this wall? For x equal to 2. So then it's going to be... So where am I going to shade? Under 8 and above the cube, right? This area here, that's the area we're talking about. If I would have said y equals x cubed, x equals 2 and y equals 0, that would have been this side here. You guys see that? So just think about what are my walls, and that'll tell you what region you're really talking about. Okay, so go ahead and try to find the area. So you have two choices here. You can either let y go from 0 to 8. If you do that, your integral is going to be dy, and all your stuff has got to be in terms of y. No idea why I did that. Or I could let x go from 0 to 2, and then all my integral stuff has got to be in terms of x, because I've chosen dx. So I love the idea of I can scan this way, or I can scan this way. I'm going to do both ways and show you, of course, they have to come out to the same answer. It's the same stupid area. Shouldn't matter which way I look at it. So I'm going to do it both ways. You guys can do it either way you want to. So currently, this is a function of x. So then it's set up for dx. So it kind of makes sense. I think most of you guys might have done that. But I could just make this x equals y to the 1/3. And now it's a function of y. And I can do the other way. So if I do it dx, scanning it across the x-axis. So as I move across the x-axis, what does y do? It goes from this to that, right? Does that make sense? Do you guys see that? So, what does x do? It goes from 0 to 2. What's on top? 8. And what's on the bottom? X cubed. Because I need everything in terms of x, right? I've made the choice. This is huge. It's huge. Making this choice tells you what the limits have to relate to, and it tells you what the inside's got to be a function of. This is going to be really big in the next section, next 2 sections, and then a lot of the next class if you take out 2. So it's got to be like this. So this integral is nice. 8 becomes 8x. X cubed becomes 1 limit is 0. That's beautiful. It's a nice, everything's x, so you don't have to worry about that, please. Be really careful about always throwing this out. Of course, if you have e in there or something, it's non-zero and shit. So I get 16 minus 4, so I get 12. Now if we do it the other way, move this up, I get some more room. So if I choose dy, So that means that as I let y go from 0 to 8, what's x doing? Going from this to that. So I let y go from 0 to 8. X is going from, what's this? I'm sorry. Y is going from, x is going from 0 to 8. Y is going in between this and this. So it's just going from nothing to x cubed. So it's just going to be, it's almost too silly. It's just going to be this. I'll get out of there, x. It's got to be in terms of y. It's going to be this. So when you write this down, it'll help you do what I just did. So I wrote x cubed down, and I'm like, oh shit, I put dy. It's got to be in terms of y. So I've got to use y to the 1/3. So see, let's see if we get the same answer. What's the integral of y to the 1/3? Y to the 4/3, so in front it's going to be 3/4 from 0 to 8. Again, one limit is 0. That's nice. When I put an 8 in there, how the hell do you do this shit? By hand. How do you do this?
First.
What's the 3 on the bottom mean?
Cube root.
Cube root of 8 is 2 to the 4th power is 16. 4 goes into 16. 4 times 4 times 3 is freaking 12. Yeah. So of course it looks very different in the middle of the work because we're looking at it in an entirely different way. But the answer's got to be the freaking same because I didn't change the area I'm talking about. I just looked at it in 2 different ways. It's sort of like a triangle. What's the base of this triangle, the way I've drawn it? This is. But can't I turn it and wouldn't this be the base then? And can't I turn it again? There's 3 freaking ways to look at that thing, but the area can't change just because I turn. Oh, the area's changing. No. Same idea here. I just turned the whole thing around, or I turned. So it's got to be the same answer. Okay. All right. Now, that's section 6.1. Let's do one more example because they get a little bit freaky. Let me take one right out of the book because I didn't make one up like this. Here, let's see. What's going to do this to me? Ew. No. Here we go. Yeah, perfect. Okay. Let's see. Who are you going to like this? So the whole thing we've been doing, but the curves are these. So the difference here is they give me a specific region for x. So it's not where do these functions meet anymore necessarily. It's, I already know I've got to go from 0 to pi over 2. Well, can you draw a rough sketch of that region? You're like, yeah, what's your definition of rough, Jeff? So cosine starts where?
1.
Yep. And then by pi over 2 it's at 0.
Why?
And the sine starts at 0, and by pi over 2 it's at 1. And then x equals 0 is another name for the y-axis. So there's a wall right there. And x equal pi over 2 is this vertical line right there. So I got a beautiful little bow tie region, right? Now there is a place of concern. Where is that? What's the function that's on top through the whole region? Is there one? No. Shit. Right here, they switch. Beautiful. So I need two different intervals, right? How do I find the area? How would I find this area here? Well, I would find the area of the frickin' square and the area of the triangle and add them up. So if I got to find areas where the definition changes, I find the area of one, and I add it to the area of the other one. Now, what is this point? I mean, you would guess that it's pi over 4, but can you prove that? Of course you can. It's very quick. What do you do to find where they meet? Well, you make sine x equal cosine x, and where do they equal each other? In this region, they meet each other at pi over 4. Sweet. Everybody cool with that? It's where they're both what? Root 2 over 2. I like it. Okay, so then what's my first integral? My first integral, what's on top? Cosine. And my second integral, of course, the top is sine. So try to set those integrals up for me, and then I'll come in and we'll go together from there. Oh shit, why did I put that there for? So funny. So the first integral goes from 0 to pi over 4. The top we said was cosine. Plus, the second integral, of course, is going to go from pi over 4 to pi over 2 to complete that. But now what's on top? Sine. So if they give you a region, so you don't have to find where they meet. They give you the region. So part of your brain goes, yay, I don't have to do that whole algebra where they meet. Yes, you do, because if they meet somewhere in the middle, you might have to make 2 integrals or 3 integrals or 18 integrals, depending on how often they cross. Don't worry, it's not going to cross more than 3 times or something. Better not, Jeff. Okay, and then this isn't too bad, right? Go ahead and finish that out if you haven't finished it yet. Let me ask you this real quick. Is it okay to get negative answers on these kind of problems? No. Definitely not. If I say I want the area between 2 curves, it will always be positive. Because it doesn't matter where the x-axis is. If I said, find the area between these curves, it doesn't matter where the x-axis is. Have I put an axis down? It doesn't matter where the x-axis is. It's going to be freaking positive, isn't it? But when I do an integral by itself, if it dips below the x-axis, of course it's going to be negative area because it's relative to the other side. But these are relative to each other. So you always have to get an actual physical area. A positive thing. Yeah, so in the book, this is an example. In the book they put absolute values around it. I personally don't think you have to, because you can just always tell who's on top when. And that's how you break your integral up. Well, this is where I want an exact answer. I don't want any flipping decimals. If one of the angles I gave you was like 5 pi over 11, then a decimal's fine, because you know shit about 5 pi over 11. This is flipping pi over 4 and pi over 2 and 0. I don't want to see any decimals anywhere. And you're like, you're not going to look at my shit, so it doesn't matter. True, but I'm on a quiz or test. What's this integral here?
Negative
Sine x plus cosine x. How do you check yourself? What's the derivative of sine? See shit. All right, no see shit. Sine goes to cosine, therefore cosine goes back to sine. So it's just like changing gears, right? You think one way with derivatives, you got to think the opposite way with integrals. And this is going to go from 0 to pi over 4. And then what's this integral going to be? Integral of sine is negative cosine. Integral of negative cosine is negative sine. So what's sine of pi over 4? Root 2 over 2, and cosine of pi over 4 is root 2 over 2. Sine of 0 is 0. Cosine of 0 is 1. Minus 1, right? Is that cool? That's big ass f of b minus big ass f of a. Remember that? Is that cool? So that's what I get when I put pi over 4 in. Bam. And then when I put 0 in, minus what I get. Bam. What do I get over here when I put a pi over 2? What's cosine of pi over 2? 0. And what's sine of pi over 2? 1. Now what do I get when I put a pi over 4 in? Well, of course I get rad 2 over 2, rad 2 over 2. What's rad 2 over 2 plus rad 2 over 2? It's rad 2. What's a half of a rad 2 plus another half of a rad 2? What's a whole rad 2? I feel like I'm talking about Fallout. It's my rads. Square root of 2. Minus 1 is minus 2. And then this minus, cancel with those minuses, and that is another one of these stupid things. You get 2 rad 2 because that's a rad 2 and that's a rad 2. You get a rad 2. You take a rad away and you're okay. Yes? When you plug 0 in to cosine, right, 0 plugged into sine is 0. 0 plugged into cosine is 1. And how do I do these limits? I do this plugged in minus this plugged in. This plugged in gave me 0 minus 1. And then when I plugged this in, minus negative, negative, so all that became pluses. Is that cool? So there's always big ass f of b minus big ass f of a. There's always a difference. Okay, I like it. Whew. Okay. So now, this is the next level of what we're going to do with this stuff. Here we go. I have a visual aid, which a student gave me many semesters ago, which I finally remembered to bring with me. It's in my backpack. You'll see it in a minute. Okay. So here's something really kind of funky. Let me put down here. Let's say this is a circle of radius 1. Semicircle. So here comes my visual aid. I might as well do it now. I wasn't going to do this one first, but now I am. Alright, so I don't know if you guys have ever seen these decorations. Look at that. I didn't even plan that shit. It almost is perfect. So what we're going to do now is we're going to rotate this bad boy. Have you guys seen these? Yes? Okay. So if I rotate that around the x-axis, if I take this shape and I rotate it around, I've created a what? Sphere. I draw my sphere. Now somehow, we are going to get, in fact, let me do this. Change this to R, just because I want to actually get the formula for it. And this was really, really kind of cool. If I rotate this,